Assalamualaikum and very good morning everyone. Again, everyone can hear me clearly? Boleh dengar? Okay, thank you Veronica. Veronica ni rajin respon. Okay, anyway, I'm not saya sakit gigi hari ni, but then it's okay. I try to finish it as fast as I can and cover as much as I can. And I hope that everyone already watched the video that I have loaded last week. It's very beneficial and it's very helpful for you guys to understand this lecture, and it's quite detailed, the videos. So anyway, for today, we're going to go through the slide for lecture 3, which is a part 2 for memory management. Okay, this is part 2 for memory management. So we are talking about RAM, or primary memory. So remember, our RAM, the capacity is limited. No matter how big is your RAM, it's still limited. Remember, because it's not infinite. So the memory manager, they need to manage the operation. Basically what they managing adalah the number of job. Remember, this is a multi-programming. There's a number of job, number of program need to be loaded into RAM. Why? Because the CPU only, the processor only execute the instruction from the RAM. Sebab tu dia mesti masuk dalam RAM dulu, and then the CPU can fetch from the RAM. Okay. So because it's limited in space, so it need to be managed by who? By the manager. So how the manager manage the allocation of the space or allocation of the memory, okay, within the RAM adalah based on the report. They have the table. Okay, I just call it report, but they're referring to the table. So the few types of table are the job table, page table, segmentation table. Last week you already learned a few, the type of the table, job table. So they will refer to this table. So in order to find where is the vacant space, so they can load the job into that space, or which job has been the longest inside the memory, so they can be removed from the memory, and then the new job can be loaded. So it depends on what method or algorithm they've been using. Paling senang adalah first in, first out. Okay, the oldest one. So the basic one. So they'll be based on the algorithm. Because remember, it's a limited in space. So they need to be smart. Okay. They need to manage which job should be loaded first. Okay, which job should be swapped out. They swap in and swap out. Okay, for today, if you refer to if you have go through the slide, you will see there's a there's a 3 actually, but yang besar dia adalah 2 lah, page dengan segmentation. Okay. Mata saya ni. Okay, there's a 2 type. Okay, after completing this chapter, you should be able to describe the basic functionality of the memory allocation method. Memory allocation method means that what are you going to allocate? Remember, you are managing the resources. What are the resources? It's the space, the partition inside the memory. So this is a memory allocation method covered in this chapter for this part. Okay, let's record. Hang on. Okay, now we are recording. All right. Okay. The memory allocation method, it can be divided into 2, page or segmented, and then, 4, page, demand paging, segmented, and segmented or /demand page. But if you can see, there's two keyword here, is page and segment. So if you understand what page mean, what segmentation, then it will be easier. So but basically dia sama je, cuma dia dipecahkan kepada 4. Okay, but the keyword is page and segmented. So the influence of this page allocation method had on virtual memory. So they will be using the virtual memory. The word virtual itself speaks to you. Virtual means there's no physical structure ataupun hardware. So for RAM, it's a physical thing and it's a hardware inside your computer or inside your laptop. If there's a virtual memory, dia tak wujud pun. There's the infrastructure less. There's no hardware. So it's a virtual. When you shut it down, so it will tak ada lah, dia tak ada virtual. Dia tak ada physical hardware. So the program can create the virtual memory. So this is what we're going to learn today. Kan? What is the relation of RAM and virtual memory? How it's helped to speed up and make the program process more efficient. Okay, virtual memory. Okay, and then there's the past replacement policy. Ni saya cakap tadi, they are using a few methods. Okay, how they want to swap in and swap out. Because there are multiple job coming in, so limited space. So they must have refer to some sort of algorithm or procedure. So they can use first in, first out, least recently used, or clock page. D is just to name a few. Okay, this is just to name a few. Okay, the mechanics of paging and how a memory allocation scheme determine which page should be swapped out of memory. Kenapa kena swap out? Because it's limited in space. They need to be swapped out. So based on what, how you want to decide. So based on algorithm that you've been using. Kalau you tengok assignment 1 awak, this is what you're going to do. Okay. Okay. What is the learning objective for this? Untuk lecture ni adalah as a working set and how it's used in a memory allocation scheme, the impact the virtual memory had on multi-programming, okay, the cache memory and its role in improving system response time. So for the cache memories, I will not really cover in this lecture because we have covered in it's a specific lecture for cache memory in your computer architecture. Ingat tak? Kita ada belajar khas untuk cache memory. So I'm not going to touch much on the cache memory. I think everyone already knows how it's work, kan? Cache memory is a sitting behind CPU and RAM. So remember the metaphor of the librarian and the backpack. So it's a smaller space. It's easier to search. Okay, it's easier to search. Okay, so it's also the size is often smaller than RAM. Okay, it's often smaller than RAM. When the job or page exists in the cache, the CPU doesn't have to go all the way to the RAM. So it's save more time and more efficient. Remember, smaller space, the search time or the seek time is lower. Okay. Today we're going to focus more on the virtual memory and RAM. Okay. This is dia punya diagram. Okay. Unit programming is easier because unit programming means that single program. Single program, so dia akan dapat CPU for that program only. Okay. This is the yang semua dah tahu kan, kalau single program one program at a time, one is done, it will be released from the memory. But now we are multi-programming, mean multiple job. There's many job in queue, they need to be processed. Who going to process is CPU. They need a CPU time. Remember, CPU only can process one job at one time, but because it's very fast, it seems to us the CPU processing many jobs at one time, but actually it's only one job at one time. But it's very fast when they do the context switching. Is for the user, we cannot see it. Okay. Okay, and then the multi-programming is a non-contiguous allocation. Okay, previously what you have learned last week is a contiguous allocation. Contiguous allocation means the whole job cannot be break into a number of parts. Dia kena satu, let's say the job size is 1 KB for example. The 1 KB of the job must be loaded entirely into the memory. You tak boleh pecah-pecahkan, dia kena as a whole job. Okay, itu contiguous allocation. Okay, for today it's a non-contiguous allocation. So meaning to say, for example, you have a job, job 1, job 2, job 3. Remember that last week where we have learned adalah the partition is fixed inside the main memory. Then you have the job size. The job size also fixed. So you must load it entirely. Katakan job size 50 tu must be loaded entirely into the main memory. You cannot break it down. Even though you only use the part of the job. Tapi kena masukkan semua. Kan? So it's a contiguous allocation. The whole thing must be loaded. Okay. And then, so today, what we're going to learn is a little bit different. It's a non-contiguous allocation. Tu yang nampak kata page. Okay, let's focus on two words here, page and segmentation. Abaikan dulu what is demand paging, what is segmented/demand page. Just page and segment. Segment. You know the segments. Segment mean that they have different segment, maksudnya different size. Like our body segments. Your head size tak sama dengan tangan, tak sama dengan your arm. It's a different size, it's a segment. What about page? What is page? Tahu tak apa page? P-A-G-E. What is page, guys? Anyone can respond? Saya pening, baik kurang respon. Jangan tidur saya kat sini seorang-seorang. What is page? Muka surat. Muka surat kan, if you look at the muka surat of your books, you see the size, are they the same size? Page 1, page 2 ada the same size? Sama kan? Sama kan? Ini buku. Mana buku saya? Jadi it's a book. Jadi it's a book. So they contain a page kan? And you see the size. It's the same size. Of course, yang fancy one you can have different size, but like the basic book kan. So the page 1, page number 2 until the last page, they have the same size. So we're talking about size here, okay? So page mean they have equal size, same size. For example, I have a job. We're talking about, we have multiple jobs. You wanted to load it into main memory. Why it must be loaded into main memory? Because remember, CPU, when you want to process the job or instruction, there must be fetch. Remember the CPU cycle? Start, fetch, process, end. Then they are looping. So they must fetch from where they're fetching from the main memory. So you banyak job kan? So you wanted to load into the memory. And remember, the main memory itself, they have partition. Kan kita belajar partition last week? So if the job cannot fit into that partition, you cannot load them into that partition. So it cannot be processed, so they have to wait, and etc. So because the contiguous allocation, the job must be like entirely, cannot be breakdown into a number of parts. Dia bagi part. So what the enhancement, the improvement is to that have been done is to do the paging. Paging, dia akan pagekan, dia akan bahagikan job ni. Let me scribble. Okay, let's say this is a job. You can see here, nampak tak scribble saya. Katakan this is a job number 1. For example, the job number 1 is maybe 50 KB. So previously, there must be loaded like entire job. Like 50 ni kena dalam main memory. When is katakan this is my main memory. Kan dia ada macam ni. So entirely contiguous. Dia tak boleh dipecah-pecahkan. What is page? Page is to break them down into a number of page. Depend on the algorithm lah, dia nak berapa page. But each of the page must be the same size. Dia kena sama size. Page buku ni sama size. So for example, you say one page size of one page. Satu page. So what's meaning to say here is 10 KB. 10 KB. Simple method, you have 5 page. 1, 2, 3, 4, 5. So let's say here only 10. 10 memory. So this job can be loaded anyway inside the RAM. Dia boleh masuk sini, dia boleh masuk sini, as long as fit the size. Kan? Nampak tak perbezaan dia guys? Kalau 50 tak boleh masuk dah. Because you not break them down into a number of like parts lah. Then when you do the page, you can break them down into smaller size, but must be the same size. Dia kena sama size. Faham tak? Before I move to segment. Do you guys get it?
Faham.
Faham kan? But what if, let's say kan, the size of the job is not 50. 45, let's say 45. One page is 10. So the last page will be using 50K kan? Ada 50 dia. 50. Here we call, remember, internal fragmentation, unused space within the partition. So dia akan jadi waste lah. Tapi at least it's a smaller, you reduce the wastage. But still you can load into the memory. So by breaking them down. Macam tu lah. Macam you ambil barang kan. You cannot sumbat in one backpack, so you break them down. Letak sini, letak sini, letak sini. So it can fit. That's the concept. Page. Paling senang, page adalah unit buku. Buku sama size. Each of the pages is the same size. It can be 50, it can be 100, it can be 200, depending on your program or system, or kalau dalam exam, depending on the exam. Kalau exam question set, each page the size is 200, so that's 200 lah. Okay, it's the size. So the rationale for this concept, so that this job can be loaded anyway within the main memory. So tak payah duduk sama lah. Sebelum ni you belajar last week, dia satu bulat tu dia mesti masuk. You cannot break them down. So now you can break them down. You can then load into the main memory. So it's a more efficient. But of course the job table juga jadi a bit complicated lah. Because you need to update the addresses. Tu yang tanggungjawab the manager lah. So to keep on updating the job table. So they know where's about. Oh, the job 1 ni. Nanti dia akan nampak ada memory tu kan. The table. Dia akan tulis lah job 1 tu dekat berapa address. Yang ni kat address mana. Page number berapa. Later on I show you the example of the table. You got the concept, right? As for the segment, it's the opposite of page. Opposite dari segi size. Remember, as I give the example of our body parts. So my arm is not the same size with my head. My head doesn't have the same size with my shoulder. So it is segment. Sama juga dengan job. When you use the page, you break down into the equal size. Remember, equal size. Often the last page will be they're gonna have the what you call waist. Macam ni lah. Kalau 45, yang last page akan page number 5 will be have 50 wasted space, unused lah. But kalau segments, it will be divided into a number of unequal size. Itu je. Size dia tak sama. So let's say they have 3 segments. You have job number 1, which is 50 kb, but you're using the segmentation. So page segment 1 will be maybe 50, segment number 2 30, segment number 3 will be 20. It will be based on the program size. Paling senang dia punya general concept is the unequal size. Page is equal size. Okay. So kalau dari segi wastage, segmentation will be dia punya wastage of unused space is almost none or lower than page. Page tu walaupun you bagi kepada a smaller space, but still akan ada wastage dekat last page. Okay. Okay, demand paging and segmentation later on. As long as you understand the concept of page and segmentation, it will be easier. Dia pasal size saja. Why? Because we want to load into memory. Ini dah sama je lah. Say improvement area can need for continuous program storage. Eliminate the need storing entire program memory. Salah saya. We are still at here. Belum lagi kat sini. Page, demand paging, segmented demand paging. Foundation for current virtual methods. Okay, need for ini nanti later on, and this next slide will cover all this point. Okay, let's see. Okay, what is the virtual memory? Okay, a computer can add more memory than the amount of physically installed on the system. This extra memory is called virtual. Virtual is no physical hardware. So kat mana you nak create the memory adalah dekat you pinjam the space in the secondary memory or on the hard disk. Hard disk storage kalau you baca the textbook dia kata disk storage. Hard disk storage is the same thing. It's a secondary memory. So literally dia ada buat space. Dia pinjam space lah. The function is similar to RAM. Okay, the function is similar to RAM, and often they will mimic lah. Dia akan ikut the same size of the existing RAM. Okay, sebab tak cukup because banyak is a multi-programming, you need more space. Okay, and then the CPU is here. CPU dia akan still fetch from the main memory. Okay, virtual memory. So here, example of the size of the VRAM and RAM. Often it will be the same size. Okay, the extra memory is called virtual memory. Kat mana virtual memory? Dekat dalam, dia akan pinjam space, make use of the like existing space inside the secondary memory or the disk storage or hard disk, same thing the secondary. So bukan you ada 2 RAM lah, you akan pinjam tempat, you just set up a booth lah kat sini. So sebab tu nama dia VRAM, virtual RAM. Virtual, dia tak ada physical. Benda yang virtual maksudnya dia infrastructureless. Dia tak ada. Virtual reality, you know virtual reality that is not real. Virtual. Dia tak ada apa. The page memory allocation. Ini tadi saya dah explain. You can see the job will be divided into a number of page. Kan? If you see later on, kalau you buat tutorial ataupun in your exam, dia akan cakap, okay, job create 5 page with this size. So it's a simple math. Dibahagikan dengan the size of page size sahaja. Okay, in this scheme, OS retrieve data from secondary storage in the same size block called page. Okay, OS kat sini dia akan retrieve data from secondary storage in the same size called page. Logical address space is divided into equal size. So dia kena ada address. Dia panggil logical address space because you have broken them into a number of pages. So you need to keep track. So dia akan ada each of these page that has their own address. Okay. Physical address is divided into equal frame. Okay, dia ada dua benda ya guys. You must know how to differentiate. Okay. Kalau page, mana pen saya tak nampak. Kalau kecil. Kalau page kalau you nampak perkataan page, maksudnya dia adalah job that has been divided into a smaller size or page. Kalau frame, kalau you nampak perkataan frame, adalah di dalam main memory. Kan? This is your main memory. Before we only use, kita cakap partition kan. So now, this is your main memory. So dia kata if you divide into equal size of frame. Kalau you guna paging allocation, you must use the size of the frame must be equal with the size of the page. So partition ni dalam main memory we call it frame. Penting ni kita namakan frame. Ini now we call it frame Okay, we call it frame. Dalam main memory. Okay, kalau you nampak perkataan page, maksudnya adalah job. Job yang telah dibahagikan, divide into the equal size. So, based on this, now you know, the page size must be equal to frame size. Untuk this method. Okay. You guys follow? Ini basic kalau you guna paging allocation, dia punya ini adalah equal size. Dia punya keywords. Then for main memory, it must be divided into a number of frame in the equal size. What size? Jobs, page size. PS sama dengan FS. Senang, paging paling simple. Sebab apa dia nak reducekan the unused space. Okay, dia nak reducekan unused wastage. Okay. Right, kita move on lah. Kita try laju sikit saya satu ni kepala dia. Okay. Ni dah tadi guys, page size memory block saya. Ni adalah lecture note yang saya ubah sikit-sikit so easier for you guys to visualize. So the page size, ni page size, page frame. One. Memory block. Sama. This is the virtual ni frame awak 2 KB, 2 KB and then so kat mana you break the job adalah using inside the VRAM. Okay, dia akan di-load dalam VRAM terlebih dahulu before it can be loaded into main memory. Okay, when it's needed, then it will be loaded into main memory. So we make use of the virtual RAM to do this paging. Kita nak break kali kat mana? Dekat dalam secondary memory ni lah, kat disk storage. Okay, kalau tengok gambar ni memang senang nak faham lah guys, and also you watch the videos, it's easier to understand. Okay, divide is incoming job. Okay, the keyword as I said is the equal size. Dia mesti equal. Page, buku, ingat buku je. Okay. Okay, memory manager task prior to present execution. Okay, sebelum you kena execute the program, okay, then determine the number of pages in program. So dia akan do some mathematics lah macam. So they need to be divided into a number of pages. So dia akan, for example, one page is 100. The incoming job is 500. So 500 divided by 100. So you're going to have 5 pages. Okay, 5 apa tadi tu address. Okay, virtual address. Okay, locate enough empty page frame in memory. Okay, load all program pages into page frame. Okay, load all program. Ni pun penting. Pen tak nampak ni. Load all program. You still have to load all program. Sebab tu dah dia punya limitation. So even though you have broken them down into 5 pages, but by using this allocation method, it must be loaded. Everything must be loaded. Cuma dia dah dibagi kepada kecil-kecil dia. Okay. The advantage of storing program contiguously, maksudnya it's not a whole. Okay. Dia senang lah, semua boleh masuk tapi different frame. But of course become more complicated. Okay, keeping track of job pages. Your table become very long. Panjang lah. Complicated kan. Yeah. Ni sama je, same thing. So this is from the textbook. Okay, you have job 1, which is the size of each job. Dekat sini dia kata kan. Job is 100 lines. Dia kata each page frame can hold Remember, page frame equals size to page size. Frame size equal to page size. Okay. The job 1 is 350. So you bahagi lah 350 bagi dengan 100. So you akan ada 4 page. You akan ada 4 page kan. But the last page ada wasted space. Okay, there will have a wasted space kat sini. Okay. And then leaving internal appear, internal fragmentation. Okay, now it can be loaded. Page 0. Nampak pen ni. Page 0, page number 1, page number 2, and page number 3. It's always start with page 0. So you have 4 pages. So it can be loaded into the page frame anyway within the RAM. Tak kisah kat mana-mana. Dia tak payah side by side. Before what we have learned is must entirely kan, satu block. Now it can be anyway as long as it's a vacant. Tapi dia kena semua. 4 page kena masuk semua. Tak boleh tinggal. Itu dia punya limitation. Kan? Right? Another issue is the page table become long lah. No, very long. Because you need to keep track the location kan. Sebab dia kena tahu kat mana dia. Kat mana. So nanti bila CPU fetch, they need to know. Remember CPU we learn in computer architecture. The most important information the CPU must have is the address. Kan saya bagi contoh Grab. Food kan, dia nak hantar makanan kat awak macam mana? It's based on your address. Then they can send the food to you or they can fetch you the Grab car. Same concept for the CPU. They need so they akan refer kepada program kata or instruction register which is all the address. So they will refer to the address. So that's why when you break them into a number of pages, so the job table become very long. Sebab dia banyak address that they need to refer. Okay. Ini 3 job table for page for tracking pages. Job table. Dalam job table dia akan contain this information only. Size of table, memory location where is PMT is stored, okay. Page map table, okay. Page map table adalah page number, corresponding page frame. Dekat mana dia letak page frame? Okay. Job 1 inside which frame? Kat frame mana ni? Frame yang remember ni adalah frame. Job 1 located at frame number 5 PMT, okay. Alright. So this is the information content on each of this table. Dia ada 3 table So our memory must have their own table to keep track. Apa dalam memory ada information adalah location for each page frame, okay, free or busy status. This status kalau free maksudnya vacant lah, maksudnya the incoming job can be loaded into that frame. Kalau dia busy maksudnya ada job lah. The incoming job need to wait until it be removed from the frame. The free busy status last week kita dah belajar. So untuk page memory allocation, there's a 3 table involved. And each of this table, this is the information, the content in that table. Okay, to keep track. The punya function is to keep track of what of the page and frame. Ini contoh dia guys. Page memory allocation. For the job size, dia ada untuk job table ada 2 information kan, job size dengan PMT, page map table. So 400 page map table location is the location. Okay, kita tengok kat sini. Job table 400, PMT location is ini sama. Sorry. Ni bila dia remove, katakan job size 200 and this location has been swapped out. So then they update the table. So the table will be like this. Dia sentiasa updating. Kalau yang in and out, dia akan keep on updating. So the new job will be loaded with the job size 700 using the same address. Ini senang je lah. To show you what it look like when the job leaves the removed from the frame and the new job loaded into the frame. Okay. Yang mana dia? Kosong ni. Okay. So. Okay, the placement is a determined line distance from beginning of this page, located line within each page frame. Ada contoh tak? Ni lah. The first line sampai the last one is dia punya this placement. Okay. Job ni kan kita dah bahagikan into 4 page. So displacement dia adalah 0 hingga 999. Then they start with 0 and 99 again. 0, 9, 100 and 199. Beginning and the last address. Okay. Yang ini yang last kali dia important juga guys. See, only 300 until 349. This is unused space, internal fragmentation. Right? Ini the page punya ID lah. Okay, and then step to determine exact location of a line in memory. Determine the page number and displace. Okay, I'm going to read it out. Okay, refer to jobs PMT. Determine the page frame quantity required page. Mana contoh dia? Often multiply page. Ini boleh baca sendiri lah. Dia ada contoh di kat sini dah. Okay, baca sendiri guys. Replacement. Ni ada cara-cara dia mengira lah. Dia boleh buat sendiri. Multiply page frame number by senang je. I think you guys CS student kan boleh buat ni. Ada cara tunjuk kat sini. Ni ada contoh. Benda ni. Ni PMT dia page 0. Okay, page 0. PMT dia page frame number adalah 5. Page 0. Frame number 5. So dalam PMT page map table, this is the information content inside this table. Okay, for page 0, dia duduk dekat frame number 5. Page number 1, dia duduk dekat frame number 3. Frame number is, you nampak frame dia maksudnya main memory. Okay, for the main memory. What is the advantage and disadvantage? I think I already discussed this with you guys. Of course, it's efficient because you break them down into a number of smaller page, so it can be allocated non-contiguous in memory. Maksudnya everywhere inside the memory. They don't have to be like in one block or next to each other. As long as there's a vacant space, a free space, so that it can be loaded. What is disadvantage? Of course, is to increase the overhead because you keep on tracking the address. And then the internal fragmentation will happen in the last page. Dia akan ada internal fragmentation. Okay, must store job. Still, you need to store the job, store entire job in memory location. Okay, although it'll be referred by CPU or not, you still need to load them all. Okay. Okay, page size selection is crucial. It's too small, generate very long PMT. It's too large, excessive internal fragmentation. Ni yang you akan buktikan dalam inside your assignment and project. You will see the differences. Kalau it's the number of job, it's easier for you to predict. Okay, page size 100 is the best best number to go. But if you have a lot of job, katakan kita bagi you 100 job or 200 job, then you have to you need to code and then you need to run it. So you need to be experimental. You change the size of the page size. Letak 100, 50, 200, 300. Then see which one is give you the less overhead or the less waste or the less internal fragmentation. Kalau number job tu banyak, memang you kena code. Kalau I give you 5 job, it's easier to do with paper and pencil. We can kira biasa. But if I give you like 100 or 200 jobs, it's impossible for you guys to kira manually. You need to code it. Sebab tu ada programming. So you just tukar the variable. Tu saja. Page size 100, 200, 300, and then you calculate which one give you the less internal fragmentation. Macam tu lah. Then you can decide which one is the best. Okay. Alright. What is the demand paging? Demand paging ni from the words demand, by request. So if the demand, then you will give to them. So senang je. Demand maksudnya you still, because this page still you need to break them into equal number of size. Kan page 1, 2, 3 sama, tapi will be loaded based on the demand only, based on request. Okay. So best swap in on demand. Kalau swap in and out to inside memory, more page fault of course. Page fault maksudnya the higher page fault maksudnya if the check is not in memory, we call page faults. Okay. Sebab dia tak semua masuk kan. But there's no wastage of page frame, no such overhead. So your punya table is not, if you compare to page memory allocation, is shorter. Okay, because you only request by demand. If they need it, if the CPU need that, then only then you upload. But still you break the job into a page, into a page lah. The same concept. So job here will be divided into equal size of page. Like previously, it must be loaded entirely into memory. But if you use one paging, this page 0, page 1, page 2 will be only loaded into main memory by request. By who? By CPU. So by request demand kan, so lagi efficient compared to page memory allocation. Page memory allocation must be loaded entirely, whether they've been called or not by CPU, but must be loaded entirely inside your main memory. Yang ni tak payah, by demand. Okay, this is the apa nama benda ni? The comparison between demand paging and pre-paging. Alright. Ni ada saya dah sebut. Okay, remove restriction entire. Is to remove the restriction entire program memory. You don't have to load it semua dalam main memory, but you still to divide them into equal size because the paging. You nampak perkataan paging kan? Okay, mutual exclusive. Tak payahlah ni. Saya nak tunjuk contoh je letak. Okay, still have three tables. Job table, PMT and memory map table, same as page memory allocation. Dia ada 3 table ni juga. Tapi dalam PMT dia ada tambahan sedikit. Dalam PMT ada few addition of the tables. Dia akan tengok the example. Dia kena ada tengok ni sebab it refer to the algorithm that they are using. Ni contohnya lah, ni contoh ni yang nampak macam complicated ni adalah yang ini je. Job table, PMT and memory map table. Contoh dia lah. Hilang pula ni. This is PMT, page map table. Okay, for demand paging, dia ada extra information as compared to page memory allocation. Page memory allocation tadi very basic kan? Mana page memory allocation? Hang on ya, sabar. Ni, dalam page memory allocation, PMT only contain page number and corresponding page frame memory address. Okay, kalau dia dah demand paging, so your PMT will have extra information. Tu je. Okay, this is dia bagi contoh lah. Job number 1, remember, is divided into a number of pages. Okay. Ni PMT awak. Okay. Kita panggil apa? Ni row Row ke column? Jadi is the page number. Apa Y ni? Y is the status. Okay, what status satu apa? Okay, and then page frame number. Ni maksudnya dia entry dia lah. Entry dia. Status dia. Modified or not. Has there been modified? Dia akan letaklah Y, yes ke, tak yes ke, no ke. And then has there been referred? Ada been referring more than once? Dia akan letak kat sini. Okay, ni page frame number lah. Kedudukan dia, lokasi dia dalam main memory. Contohnya PO dekat 5. PO mana? Mana page 0? Page 0 job 1. Ni. Job 1, page 0, 5. Page 1, job 1. Page 1, job 1 mana? 9. Dapat bateri. Lupa cucuk ni. Alright, okay. Tu kegunaan page ni lah. Nampak macam complicated tapi tak ada apa pun. Each of the entries will give you the information. Okay, where about, kat mana dia located. Then has there been referred, has there been modified. Okay. Okay, swapping process. For swapping process is like you swap in and swap out. From where to where? from secondary storage to main memory. You swap in, you masukkan. You swap out, dikeluarkan daripada main memory. Okay. Of course, it based on the algorithm bawah. Okay. Hardware instruction. Patch fault, ni kita akan tunjuk contoh senang nak. Later on ada little bit calculation in order for us to understand apa maksud patch fault. Patch fault maksudnya when CPU want to fetch particular job or page or instruction from main memory, it is not exist inside the main memory, kita panggil fault. Tak ada. Bila dia cari tak ada, dia panggil fault lah. So they need to load it into the main memory. Itu maksud patch fault. Okay. Thrashing maksudnya adalah excessive amount of page swapping between main memory and secondary. Maksudnya terlampau swap in out is too frequent. Dipanggil thrashing, is not efficient. Due to main memory page removal that is called back shortly thereafter. Lepas dipanggil, di swap out, di swap in, di swap out, swap in. So dipanggil thrashing. Dan you akan tengok ratio dia lah. Kita akan tengok terus kepada contoh. It's easier to understand rather than you baca ni. First out, page replacement. Okay. Ni ratio dia. For example, no so good, FSC is 9/11. This is the number of job. And then 82%. Maybe we can show you the calculation. Jadi contoh you have divided the job into a number of page. For example, we keep the page AD, A, B, C. So now, let's say the CPU request ini dalam main memory A, first they refer to A. Okay, A will be loaded into. Katakan ada 2 frames sahaja. Let's say you have only 2 frames inside your main memory. So A and B is the first to arrive. So A here, B is here. So the next request will be C. Remember CPU nak ambil C, tak ada, tak wujud. So it's a patch fault. So C akan be, so between these 2 page, which one will be swapped out? Let's say you're using first in, first out, A will be swapped out, but they're the longest inside the main memory, so C will be loaded into the page frame number 1. Okay. So now here will be, mana ni? Here will be. Dan now later on dia nak A. A tak ada dah dalam, B is inside your main memory, are not frame kan. So A tak ada because you only have 2 frames. So B is the longest inside the main memory, so B will be swapped out. So A will be loaded back. And the next one will be B. B baru je keluar kan, so you keluarkan C, masuk B. Lepas tu D. D tak ada kan, so mana yang the longest inside the memory is A, so you loaded. Then what else? B. Ada tak B? B is already inside the memory, so you don't have to call it back or swap it in or out. So B is here. So he is a hit. Hit maksudnya dia ada lah. So then A. A is not inside the main memory. So B and D you have to compare. Which one is the longest inside the memory or which one is the recently used? D is depending on what algorithm you are using. Kalau you using FIFO, so you need to keluarkan D. So you keluarkan D lah. Because it's the longest, walaupun you baru refer, because you're using the FIFO. If you use the D LRU, then you swap out D. So kita keluarkan B, so A can be swap in. And then sampailah habis. Remember, it must be following what algorithm you are using. Banyak lah kan, banyak macam-macam. Ni kalau senario ada 2 frame sahaja. So in and out, swap in, swap in, maksudnya load into memory. Swap out, remove from the main memory. Alright? Ini contoh kiraan. Okay. This sama, this is the same example from the previous page. So now you want to calculate the ratio, whether it's a good ratio or not. So for example, you have 2 frames. Ini paling penting, katakan dalam exam or in your assignment, you must be aware of how many flash frames you're going to have. For example, here in D is just for the sake of this financial detail, 2 frames. Ini lebih kalau susah nak lukis kan. So frame 1 and frame 2 meaning to say in your memory ada 2 frames sahaja. So D is the pages. page A, B, A, B. So, according to the request lah. So using the first in and first out algorithm. So at first, yang mula-mula sekali, page frame kosong. Kosong kan? It's a 1, 2. So the first one adalah A. So CPU request for A. So it's empty, both is empty. So the A is not exist yet inside the memory. So it's a fetch fault. Remember fetch fault bila CPU request dia tak ada. Okay, so dia kena ada asterisk kat sini. Put asterisk. Yeah. So A will be loaded into the fetch frame 1. Here. You slide Windows slide kan. So now fetch frame 2 is still available. Right? What is the second request? The second request is B. Fetch B. Oh, B tak wujud. Tak ada pun dalam fetch frame in either of these fetch frame. So it's a fetch fault. Dia akan letak asterisk. Menandakan it's a miss lah. Tak ada. Tak wujud. So B will be loaded into the available frame. So B will be loaded into frame number 2. So at this frame, 2 frame is occupied with page A and B. So the next request is A. So if you nak A balik. So bila dia request A is already inside the memory kan dalam frame. So there's no page fault. Tak ada. Because it's already exist. Ada. Tak ada swap out berlaku. Tak ada swap in berlaku. Okay, there's no fault. Dan dia bergerak ke sini. Bila dia bergerak ke sini, now see. Remember, you only have 2 frames. So it's limited. So which page need to be swapped out? How you want to decide is depending on what algorithm you are using. Now we are using FIFO, first in, first out. So meaning the longest inside the memory must be swapped out. So you need to compare lah yang mana yang the longest inside memory. So you can tengok lah A ni, paling senang tengok A dan lama kan compared to B. So A will be swapped out. A akan di swapped out to make room for C. Kan, C tak ada dalam memory, so ada asterisk. Maksudnya when does not exist in memory is a miss. Then A. Lepas tu dia nak A balik. Currently, so want to make room for A, you need to do the swap out. Which page need to be swapped out? The longest inside the memory. So it will be B. Jadi, to make room for A. So it's a miss. Kenapa it's miss? Because A is not inside the memory when they first request. Lepas tu B, dia nak B balik. Currently it's C and A. So you need to compare which one is the longest inside the memory. Tengoklah C, B. Maksudnya C. Swap out C to make room for B. So it's a miss. Okay, sampai dah habis. Boleh faham tak guys? Saya tak payah sampai habis. Do you guys get it? Boleh kan? Dah senang je. So then,
yes. Yeah.
Thank you. Then you calculate the ratio. You kira dah ratio. You panggil error ratio kan. So you kira berapa asterisk ada. Mana ni? So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 per 11. You darab dengan 100%. Dekat next slide dah ni. 9 je. So access ratio dia berapa? So you kira. Akan dapat lah. So you need to compare. Mak dia tak tunjuk. Untuk LRU dia 8. Compared to P4. LRU hanya 8/11. FIFO sekarang 9/11. Tengok LRU. LRU is the least recently used. Yang tidak digunakan banyak. I can explain how je. Okay, the same scenario, the same number of page required. Also sequence sama. Okay, A and B, kalau they're not inside the memory is a fault. So ada asterisk ke sini. So dalam B masuk Now A. Swap out macam biasa. Now ada C. So we want to swap in C. So you need to compare A and B. Which one you want to swap out? Remember we are using recently used. Okay, you akan tengok mana yang tak di recently used. So you compare A and B. A you just use it. You just use A recent. You baru je gunakan A. Although it's the longest inside the main memory, but you just recently use it. So you will swap out B. Itu beza dia. Sebab you baru je guna A. Walaupun A is the longest inside the memory, but you just use it recently. You just refer to it. So B will be swapped out. Now to make room for C. Remember, because it's a miss, you put asterisk. Now A is call again. But A is already inside the memory, so there's no swap in and out. Right? The next, the B, request B. So B, you need to swap in B into memory. So you can compare A or C need to be swapped out. You just recently use A. A baru je dipanggil. Okay. So you swap out C. Even though A is the longest kan. Inside the keluarkan C to make room for B. Tu beza dia FIFO dengan LRU. LRU adalah yang baru digunakan. Yang baru digunakan tak boleh dikeluarkan even though they're the longest inside the main memory. Compared to FIFO, although they've been requested repeatedly many times, but if they're the longest inside the memory, you have to swap them out. Okay? Kalau LRU tak. In this stage, LRU is better than FIFO. When you do the calculation, you kira lah berapa miss dia. The asterisk ni. 1, 2, 3, 4, 5, 6, 7, 8 per 11. So it's slightly better as compared to FIFO. FIFO tadi 9 per 11. But this, the job number is not that many. It's so hard for us to determine. So that's why you're doing your assignment and your project, you're going to see the differences. So setiap kumpulan tak akan bagi jawapan yang sama. Ada kumpulan akan kata FIFO the best, ada kumpulan akan kata LRU is the best and so on. Okay, but you need to code it and run it for you to get the answer. Kalau dia kecil macam ni, it's easy for us to calculate it manually. If you're given a lot of numbers of job, numbers of frame, then you have to do it. You need a computer to help you to calculate, right? But the most importantly is for you to understand the concept. You understand the definition, how it's work. Tadi page tu apa, segment tu apa, FIFO tu apa, LRU tu apa, and what is the page for? Apa maksud dia ni? If the recipe request for that particular page, but it's not existed in a main memory, so it's a page fault. So you tanda dengan asterisk, interrupt. So they need to load it from secondary storage into the main memory. Okay, itu maksud dia. Yang saya skip, please read on your own. Benda ni tak ada apa, dia just to give you the status bit. Okay, kalau satu maksudnya dia ada dalam memory. Ni just the PMT table bit meaning apa, status bit indicates if page is other in memory or not. Reference bit means they've been referred recently. Okay. Modified bit indicate if page contents altered, ada tak diubah. Inilah contoh dia apa. Kosong not in memory, 1 reside in memory. 0 maksud dia not modified, 1 was modified, 0 not called. Okay, ni baca ni. Ni working set, let me read first. Working set is kan page tadi divided into a number of pages, so it's a working set. Okay, a number of pages allowed for a working set. Set of pages residing in memory accessed directly without incurring a page fault. A number of pages that can be reside inside one memory in memory at one time. Okay, itu semua maksud dia. Contoh dia macam ni lah. Timeline showing the amount of time required to process page. Apa benda ni? Tak apalah. Sekejap And then the point is additional to load the necessary page. What example is this? Oh, okay. Oh, this is the walking set example. They show you the what is the turnaround time. Okay, need to process the whole thing. So from the beginning is 30 seconds. It's a timeline saja lah. Ini tak ada apa lah. Oh, ini segmented. Saya dah explain what is segmentation. Okay, it's the concept is same with the page. Cuma size dia tak sama. Okay, it's a different size. One for each module containing related function can reduce the false fault. So you nak reduce false fault dia. Main memory no longer divided into page frame. So main memory tak ada divided into a page frame. Now allocated dynamically. So tadi ingatlah page frame size sama dengan page size. Dia kena sama. Kalau page size awak 100, page frame awak pun 100. Kalau you use segmented memory allocation, so you can allocate them dynamically. Ingat tak dynamic partition? This is the same similar concept. Okay, the job will be divided into a number of segments. Each segment have different sizes. Okay, and then what about memory? How are you going to divide the partition inside the memory? So this sama concept with dynamic partition. So the allocated dynamically. So there will be segments size. Okay. Inilah kita contoh segment 0, 1, 2. You can see the difference in sizes. Okay. Ini contoh dia loaded into the memory. You can see the different size here. Okay, they be allocated dynamically. Maksudnya dia ada flexibility lah. So this is a SMT. So dalam segmented memory allocation, you akan ada segment map table. Dalam page map table tadi, you ada PMT. Ya, ingat tak? PMT, page map table. Kalau segmented, you ada segment map table. To keep track lah. To indicate where segment 0 reside inside the memory. Kat mana? So, you kena ada address dia. Sebab nanti CPU, when they want to fetch, they will be based on the address. Okay? Okay, now sama lah in memory or not in. Kalau not in memory, maksud dia dekat di storage, dekat virtual memory tadi. Sebab you're not going to load them entirely, tak perlu semua. Okay? Inilah ni contoh macam complicated, tapi sebenarnya sama saja. This is to give you visualize okay, how they are loaded into the main memory. Kat mana? Ni SMT dia. Nanti balik ni you kena analyze, tengok balik. Tengok, tenung balik benda ni. So very simple. This is the address. Kan? This is the size. This is the address. Dekat address 4000 dia. It's the segment number 0. Kat sini. Semua ada. Call subroutine A. Sini lah. Keep track. So SMT, apa dalam SMT adalah semua ni. Ada this information. Dia macam complicated kan sebab dia dah segmented and then they can be like loaded like dynamically into memory. Okay. Ini just a definition. Job table dalam tu apa? Segment map table, a list detail about each segment kan, setiap segment. Memory map table, monitor allocation of main memory. Okay. Ini baca sendiri. What is the advantage over page memory adalah page allocation is the internal fragmentation is removed. Kalau dalam page memory allocation, the last page will have internal fragmentation because it's fixed in size. Kalau what is the disadvantage? Disadvantage ni this similar to dynamic partition. You know last week last week we have learned about dynamic partition. It's quite similar. It's dynamic at first. It's flexible at first. Okay, it's difficult managing variety length segment in secondary storage because it have different sizes. So, but still we have external fragmentation. Okay, remember kena tahu differentiate internal and external fragmentation. Internal is within the partition itself. Itu internal. Okay. Ni baca sendiri lah. Saya dah sebut benda yang sama. Smaller than most. Yeah. Ni is information content in each of the table. Okay, sekarang dia kata segmented / demand page. Now they combine these two algorithms, they combine into one, they create one algorithm. Okay, segmented demand page. So if you're using this scheme, so there's 4 tables needed. Job table, SMT dengan PMT. Sebab you dah gabungkan dua memory allocation. Page dengan segmented by demand. Tapi by demand lah. So, in short, the job will be divided into an equal size, which is segments, but only be loaded into memory by demand only. So, dia lagi better. Kalau PMT tadi, equal size, must be loaded entirely. And then demand page, still equal size, but only be brought into memory by the demand. Sekarang dia nak gabungkan SM segment plus demand page. Maksudnya the job will be divided into an equal size, which is a segments, based on the subroutine program size, but only be brought into memory by the demand. Digabungkan dua algorithm to create improve algorithm. Faham? Ini dah. Tapi this is the need to maintain this 4 tables, so it's more complicated but it's more efficient. Logically, the more advanced the technology or algorithm, of course it become more complicated, but it's more efficient because they wanted to reduce the internal and external fragmentation. Ini dah advantage dia. Sendiri. Ini associative memory ni, I'm not quite sure. Yang ni kita cover dalam CA, I'm not quite sure what it's appear here again. Tapi you boleh baca sebagai sebagai pengetahuan sajalah. It's quite complicated. Dia ada register. Remember, register is to hold address temporarily. Ni tadi kita dah discuss what is a virtual memory. The cooperation between memory manager and process hardware. Job size not restricted to size. Allow an unlimited amount of multi-programming. Sebab dia punya size daripada hard disk. Hard disk size is bigger. So you can create more space. Yeah, acting like a RAM. Okay, tapi still need to be loaded into RAM when you're using. Because you not break them into a number of size, so you need a space to hold that information. So dekat virtual memory, dekat VRAM. Okay. Alright. Ni baca sendiri boleh guys, dia baca sendiri ni. Ni ada perbezaan dah. Paging dengan segmentation. You can read on your own. Kan. Kita dah discuss just now. It's just that you want to proper wording, so you read this slide. Cache tak payah cerita lah. Cache you already know, and the upper function of cache is a smaller size. Just remember the backpack scenario in librarian. Okay, in librarian. Jangan get confused with cache dengan VRAM. Don't get confused because when you divided a number of jobs, it's happening in VRAM. It's not in cache. Okay. Cache tu you can imagine as sitting ni. Ni bagus ni. Okay, CPU, memory, secondary. Here is VRAM. When you want to pinjam the space, you pinjam from this storage. Okay, so VRAM will be created here before you load the incoming job into memory. Remember, your memory is limited in size, so you need another space, just dalam secondary storage. Okay, now you ada cache memory. Cache memory ini is a smaller space. It's a smaller space. Okay, when you loaded, katakan CPU panggil A, dia akan masuk ke dalam cache memory. So when they wanted to request for A again, dia akan refer to cache memory first. Kalau tak ada, then it will go all the way to main memory. Okay, dalam memory dia kecil, A ada tak? Kalau A tak ada, so they need to do the what process? In and out, swap in and out. So dia akan swap in A from secondary storage inside the main memory. Itu dia punya aturan. Don't get confused. Okay. Okay, boleh faham tak gambar rajah ni guys? Can you guys understand? Boleh. Oh, thank you. Itu je, you kena faham dia punya structure. Digesting. Banyak sangat maklumat kan, but actually you already learned cache memory in computer architecture. Ingat yang backpack librarian. Ingat CPU when they want to process, they must fetch from main memory. But having the cache dengan VRAM is to make it more efficient. But still it must be fetched from main memory inside your RAM. Tapi memory is limited, so they need help. Dia akan ada cache, dia akan ada secondary storage because the incoming job is from here. You banyak job kan, job 1, job 2, multi-programming, so dia ke sini. So then you use a paging allocation, so dia will divide into a number of page. Kat sini dah dia berlaku. Baru dia load into main memory. So CPU will fetch from here. Kalau ada cache, dia akan refer to cache first. But cache punya information adalah daripada main memory. Sebab itulah Mickey Mouse tu penting guys. Mickey Mouse awak kan, CPU main. Hai benda ni. Main dengan IO. Pas kan? So CPU is a processor. What are the processing job instruction? So where they got all this job or instruction is from memory. When you boot up your system, everything will be loaded into main memory because it's limited in size and it VRAM. To speed up the access, they'll introduce the cache. Macam tu. Boleh dia pusing kat situ je. Sebab tu dia kata you have to understand the concept. Kalau understand the concept, it's easier for us to understand more. Of course, yang kita belajar dalam OS and CA is quite basic, okay? Fundamentals of computer system. Yang ni penting gambar ni. Ni baca sendiri. Ni pun sama. Ni summary sama. Okay. Tapi kalau if you not still understand, tapi the keyword is you must tahu apa itu page, apa itu segment. It's the job size, the job that divided into an equal size or equal size. They're happening inside your VRAM. Okay? And then you must know page itu must be loaded entirely. Tak boleh tinggal-tinggal. Semua kena masuk dalam page frame. When you use page memory allocation, your memory must be divided into an equal size of frame. Okay, kena. Kalau segment, unequal size. So in your memory, you don't have to divide them into like a number of partition. So dia akan sama dengan dynamic partition. Similar. Okay. Then demand, maksudnya by demand only. By demand, it will be brought into main memory. Kalau tak ada demand, dia duduklah dekat VRAM itu sahaja. Okay. Terus sakit. I think that's it for today's guys. Okay, next sim. Tapi kena baca lah, as again you have to read this lecture slide carefully, analyze all the yang gambar-gambar yang kita include ni. Sebenarnya kalau you ni sangat senang. So you analyze all this diagram, these figures, the explanation inside this lecture note itself. Okay. Yang ni saya tak yang warna-warni ni saya tambah lah. Basically ni yang kita belajar hari ni. This is what we have learned today. Yang ni yang warna orange ni. Okay. So for your tutorial, actually we're going to do like similar with tak ingat dengan CA, where you can try to answer that question interactively. So I will load all the question and answer inside the e-lib. So far until today ada 3 tutorial kan, which I haven't uploaded it yet. So nanti you can try it. Okay, kita boleh try it and then I'll make sure that before your exam kita akan discuss lah some of the question from the tutorial. Okay, but actually today I wanted to discuss tutorial number 2, but I don't think I have enough time to do that. It also sangat gigi. So hopefully next week kita back on track lah, which is before we start with class, we do tutorials sedikit lah, 1 atau 2 questions sahaja. Okay, I think that's it for today's guys. Hari ni saja.
Ada soalan.
Apa?
Ada soalan medium.
Ada soalan? Mana soalan?
Nanti kelas nanti kelepasan PRU nanti kita kelas online ke medium?
Okay, for PRU actually we are asked to do it hybrid. Hybrid, you tahu kan masuk hybrid kan, which is Ada face to face, ada online. Okay, I wanted to ask every single of you, is it okay if we done it online only until midterm?
Yes.
Boleh tak?
Yes.
Yes, oh cepat je yes tu. Kalau semua okey, tak ada masalah sebab dia kata hybrid tau. Hybrid tu is a combination of face to face and online. Saya tak boleh bagi veto cakap let's do it online. I need to ask. So if you guys okay with online, then we'll do it online lah until midterm break lah. Balik mengundi ke semua?
Balik.
Balik ya, baliklah. Okay, kalau macam tu, starting next week kita buat online sahaja ya. Sampai baru kita discuss again. For your midterm break, is online quiz, so easy. Okay. Midterm nanti pun online. Saya baru dibagi tahu oleh course coordinator. Please sila let's go. Okay, I think that's it for today. For those who haven't scanned the attendance, I will reshare again the...
Excuse me, madam.
Oh yes, apa tu?
I have questions about the assignment.
Yeah, Simon, what is the question?
Is that the both job can execute the I/O cycle at the same time or not?
No, cannot.
Cannot. It's the same as the CPU cycle, right?
Sama.
Okay.
That's the quick question.
Okay.
Remember guys, kita kan dah belajar context switching kan? So it can at the same time. Tapi nanti untuk assignment 1, can you guys do it separately? Maksudnya I/O saja, CPU saja. Nanti later on the project baru kita do the assumption.
Okay. So only one job can do one I/O cycle, right? Okay.
Yes, correct.
Okay. Okay, thank you.
Okay, untuk group semua dah ada kumpulan. Sebab saya tengok ada satu kumpulan sikit orang je. Kalau dah ada tak apa. Okay, let's say you having a problem finding a group member, please let me know. So you boleh masuk group number 1. Hanya group number 1 yang tak ramai. Kalau siapa yang belum ada kumpulan, please join group number 1. Okay, for those who haven't have a group yet, please join group number 1. Group lain dah penuh dah. Kalau ada lah. Alright. Okay, I think that's it for today guys. Thank you for listening. Itu sahaja. Next week will be online classes. So please be aware, be alert with my elite announcement. Okay. Kita kelas Senin ke Selasa ke. Please be alert. Okay. Usually I will post it paling lambat on Friday if I have class on Monday or Tuesday. Just make it via email and elite. Okay. Thank you guys. Okay, bye.
Thank you, madam.
Sama.
Thank you, madam.
Thank you, madam.
Okay, selamat mengundi. Belum lagi mengundi. Nanti saya share siapa belum scan. Siapa dah scan, you can leave the class. So I will keep this on for maybe 2 minutes.